Hey everyone. In today's video, we're going to take a look at how to graph linear inequalities, specifically looking at inequalities that are in standard form. Okay, so we know from prior videos how to graph a linear equation in standard form. You can graph it using the intercepts, or you could get it equal to, set it equal to y, and make it into slope-intercept form and also graph from there. This one, we have our intercepts. Okay, everything's divisible by 16, so we're going to go ahead and use our x and y intercepts to graph this one. Okay, so if we recall, to get the x-intercept, we kind of cover our y and do 16 divided by 4 to get the x. Okay, so our x-intercept, 16 divided by 4 gives me 4. To get the y-intercept, I cover the x, okay, and I do 16 divided by -8. That's going to give me -2. Okay, so there is my line. Okay, we know it's going to be dashed because we do not have the line underneath. So I'm going to go ahead and make it dashed. All right, and now we need to test to see if our origin is going to be a solution. So I'm going to use the origin to test, which is again 0, 0. And we'll plug it in and see what we get. Okay, so I get 0 less than 16. Is that a true statement? 0 is less than 16. Okay, so that means that I'm shading everything on the same side as the origin. Because the origin is a solution. All right, let's take a look at another one. Again, if this was also not a solution, that would mean that I would shade on the opposite side. Okay, so if this said no, not a solution, then it would shade on the opposite side. Let's take a look at another one. Okay, graph the linear equation, -3x minus 2y less than 10. Now we see here, this one, 10 is not going to be divisible by -3. So this one, we're going to have to get y by itself. Okay, the first thing I can do is add 3x to both sides. Okay, so I get -2y less than 10 plus 3x. Okay, now I have to get y by itself, so I need to divide by -2. And when I divide by -2, I divide everything in my equation by -2, so I get y. Now this is an interesting part here. Because it's an inequality, we know that whenever we divide an inequality by a negative number, we have to flip the sign. The same rule applies for linear inequalities. So similar to when we solved inequalities in the beginning of the year, or in one of my earlier videos, you have to flip the inequality. So I turn it from less than to greater than, and we'll go ahead and write out the rest of our equation. Okay, so my starting point here is -5. Okay, now my slope is -3 over 2. I could go down 3 to the right 2, which is off the graph, or instead I could go up 3 and to the left 2. We know that could go either direction. And again, we do not have the equal to, so this is going to be a dashed line. Okay, same rule. We have to now see if our origin is going to be a solution or not. Okay, so let's go ahead and plug in 0, 0. Okay, so I could plug it into any of them. I'll plug it into this last one, -5, -3 over 2 times 0, and we get 0 greater than -5. This one actually happened to work out as a solution as well, so that means that we are going to shade on the same side as the origin again. All right, so again, if it's standard form, you could graph it one of two ways. You could graph it using the intercepts, just like we did in those prior videos. And also, if you can't use the intercepts to graph them, you could also get y by itself, get it into slope-intercept form, and graph it just like that.